After the last video, considering coordinates on the unit circle related to multiples of pi over 6, we've now reached a point where we have 16 points on our unit circle that are related to the special angles. So that is quite a bit of information, and I want to use this video to come up with a way in which we can recreate the unit circle without memorizing a picture of it. Okay. So the way I'm going to do this, if you look at a picture of the unit circle or any of our previous videos, when it comes to the special angles, all the coordinates are some combination of these 5 numbers: 0, 1/2, 1 over radical 2, radical 3 over 2, and 1, positive or negative. Okay. These numbers are ordered in increasing order on the board, and I can use this ordering to help me develop my circle. So here is our unit circle. Let's focus on quadrant 1. That point is 1, 0. This point is 0, 1. And I know that there are 3 points in between related to my special angles. Okay. Let's focus on the x-coordinates. This x-coordinate is 1. It is the farthest away from the y-axis. This coordinate, this point is going to have the next largest x-coordinate. Well, the next largest x-coordinate must be radical 3 over 2. This point must have the next largest, 1 over radical 2. And then finally this point must have the next, 1/2. Right? And then we have the least, 0, since we've reached the y-axis. Right? Let's think about y-coordinates. Starting at this point, y-coordinate of 0, the y-coordinates are going to increase as we move up the plane. So 0, the next one is 1/2, 1 over radical 2, radical 3 over 2, and then finally 1. Okay. So there, I put down all the coordinates in quadrant 1 that are related to special angles. Okay. To complete the circle, I can either think in terms of this ordering, or I can just use symmetries. And I think symmetries is quicker, so let's do that. To move my points from this side to the mirror image on the left, I'm just going to make the x-coordinates negative. Okay, so there, I've done the top half of my unit circle as far as the special angles are concerned. So for the bottom half, I'm again going to use the symmetries of the circle, realizing that the bottom half should just be the mirror copy of the top, right? So I'm going to make all my y-coordinates negative. And going about the circle in this fashion, we are going to get all 16 points that we care about when we're thinking about special angles. Okay? So what about those angles? Well, a number of ways to think about it. I like to just count starting from 0. Let's first count the multiples of pi over 6. Knowing that this one is pi over 6, this one is 2 pi over 6, which is pi over 3. Let's go ahead and reduce it. 3 pi over 6 is pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6. 6 pi over 6, which is just pi. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6, 3 pi over 2. 10 pi over 6, 5 pi over 3. 11 pi over 6. And then 12 pi over 6, which is just 2 pi. Okay. So I've done all the multiples of pi over 3. What about the multiples of pi over 4? Well, this one is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay. So thinking our way around the circle in this fashion, we are able to reconstruct it without having to memorize the entire picture.